Today, India stands at a pivotal moment in its history. Look around. Modern skyscrapers touch the clouds. Satellites orbit overhead, sending signals that connect our nation. From metros running beneath our cities to the defense systems protecting our borders. From the smartphones in our pockets to the spacecraft exploring the cosmos. Every single achievement rests on a foundation of metals, minerals and advanced materials. India is now the world's second largest steel producer. Our steel consumption grows by 9% annually. Every bridge we construct, every vessel we launch, every technological milestone we reach carries within it decades of scientific innovation and metallurgical precision. But what makes all of this possible? What allows a nation to transform itself from colonial dependence to industrial mastery? The answer lies not in one moment, but in a 75-year journey of vision, persistence and relentless innovation. It lies in an institution that has quietly, steadfastly shaped India's technological DNA. While headlines celebrate India's infrastructure triumphs, few ask the fundamental question: where does the strength come from? Who ensures that the materials we use are strong enough, pure enough, and sustainable enough? Who pioneers the technologies that make self-reliance possible? For 75 years, one laboratory has answered that call. In the steel city of Jamshedpur, CSIR National Metallurgical Laboratory has stood as the invisible backbone of India's industrial transformation. Without it, none of India's growth story would have been possible. Every time India needed to reduce dependence on imports, NML innovated. Every time we faced a materials challenge that others said was unsolvable, NML found a solution. Every time a new strategic sector demanded indigenous expertise, NML delivered. This is the story of silent strength. The story of how one institution has continuously forged India's future.
Over the last 7.5 decades, CSIR-NML has served India's core sectors: steel, non-ferrous metals, atomic energy, defense, space and aerospace, contributing research, process innovations and pilot scale demonstrations. In doing so, we have anchored our heritage of research in metals, minerals and materials while preparing for new demands, changing raw material scenarios, sustainability imperatives, new alloy systems and digital process controls.
The year was 1942. India was fighting for freedom, and one visionary scientist, Sir Shanti Swarup Bhatnagar, was fighting a different battle. He envisioned a free India that was not merely independent politically, but self-reliant scientifically and technologically. On 1942, September 26th, the Council of Scientific and Industrial Research was born. CSIR, designed to be the innovation engine of a newly independent nation. Among Bhatnagar's ambitious blueprints were 5 pioneering laboratories, each destined to transform an entire sector of Indian industry. One of these laboratories would become the cornerstone of India's metallurgical independence. The National Metallurgical Laboratory. On 1946, November 21st, C. Rajagopalachari, India's first and only Governor-General, laid the foundation stone in Jamshedpur. 4 years later, on November 26, 1950, Prime Minister Jawaharlal Nehru arrived to formally inaugurate the laboratory. His words that day encapsulated a nation's hope. "I dedicate this laboratory to a nation in a spirit of faith in the future." The laboratory received generous support from the House of Tatas, which provided the required land and contributed significantly to its infrastructure. Strategically located near several mines and close to India's first British capital, the laboratory found its home in Jamshedpur, the heart of Tata's visionary steel city, making it an ideal site for metallurgical research. As CSIR-NML began to take shape, it was the unwavering commitment and philanthropic vision of the Tata family that gave the dream a tangible foundation. Original correspondence between J.R.D. Tata and Dr. S.S. Bhatnagar, along with the Sir Ratan Tata Trust's donation, provided crucial support that transformed the idea of NML into reality. These historic documents are lasting proof of industry's faith in India's scientific vision and mark a defining partnership that helped build the very foundation of CSIR-NML. The National Metallurgical Laboratory, popularly known as NML, was established with the mission to offer technical support to industries, analyze metal content in ores, develop efficient extraction methods for commercially viable metals, study their properties, and process them into usable forms. Through these efforts, industries such as steel and copper could not only drive economic growth but also enhance their global competitiveness. But it was the vision of its first Indian director, Dr. Balraj Nijhawan, a Sheffield-trained metallurgist who understood that freedom meant mastery, that transformed NML from a laboratory into a movement. Dr. Nijhawan understood that India's metallurgical independence required more than buildings and equipment. He demanded innovation laboratories, pilot plants, and research programs directly aligned with the nation's industrial ambitions. His work on armor plates, nickel-free stainless steels, and indigenous alloys laid the foundation for everything that followed. Meaningful work touches lives in countless ways. Aligned with the nation's vision of self-reliance and indigenous advancement in industries and technologies, NML began impactful contributions right from its inception by harnessing the country's own natural resources. Remarkable achievements followed in the late 1950s when NML successfully developed processes using locally available raw materials to produce metals and alloys, resulting in substantial savings of foreign exchange. In 1959, NML commissioned its first pilot plant, among the world's largest low-shaft furnaces for iron making, marking a major step in its technological journey. Another noteworthy accomplishment was the creation of nickel-free stainless steel, an innovation born out of the limited availability of nickel in India. To address the high cost and shortage of copper conductors, NML launched an aluminium alloy development program in the 1960s. The resulting alloy, famously known as NML's PM2 conductor, was later produced on a large scale by numerous small-scale industries across the country. Installed in February 1962, the 500 kVA submerged arc furnace remains operational to this day, continuing to produce a diverse range of ferroalloys. The 1970s witnessed another breakthrough when NML pioneered direct reduction iron making technology. This led to the establishment of India's first commercial sponge iron plant, with a capacity of 30,000 tons per year, commissioned in 1975 at the Andhra Cement Company site in Vijayawada. These achievements empowered India to build its own infrastructure, energize its industries, and secure its borders.
Today, NML stands at a critical juncture, where tradition meets transformation. Our agenda now emphasizes innovation aligned with national priorities: Make in India, Atmanirbhar Bharat, Digital India, and Vikshit Bharat 2047.
Between 2001 and 2024, CSIR-NML conducted around 80 failure investigations for the Indian Air Force. strengthened by a 2020 umbrella agreement that underscores the strategic importance of materials science. NML has evaluated materials for nuclear power plants, qualified materials for INS Vikramaditya, and completed analysis for INS Ekshila, supported by Asia's second-largest creep testing facility. Its ongoing work includes life assessments for rail, petrochemical, power, and chemical sectors, aided by advanced characterization capabilities at the NML Madras Center. Notably, NML also developed a space-qualified ultrasonic flow meter with ISRO for precise spacecraft fuel gauging, with potential use in the upcoming Bharatiya Antariksh Station.
We are convening and hosting forums for industry thought leadership. That is the Industrial Conclave on Maritime Corrosion Management at our Marine Corrosion Research Station, MCRS, Digha, as well as Industry Conclave for strategic sectors, where we are engaging with defense, aerospace, materials manufacturing sectors to develop indigenous material solutions. These developments signal a shift from being a purely traditional metallurgical laboratory to becoming a proactive hub for modern materials challenges, sustainable processes, digitalization, and strategic metals research.
Today, India imports more than 90% of its critical metals. These materials are essential for defense systems, space exploration, renewable energy, and advanced electronics. In 2023, India's Ministry of Mines identified 30 critical minerals for the nation's future. CSIR-NML is actively researching 16 of them. To mark 75 years of CSIR National Metallurgical Laboratory, organized CRICMET 2025. Critical Metals Congress, India's first of its kind offline event dedicated to critical mineral processing and metal extraction. This landmark event brought together leading scientists, policymakers, and industry stakeholders, reinforcing India's commitment to securing its future in critical materials. CSIR-NML leads the Center of Excellence for Critical Minerals under the National Critical Mineral Mission, advancing research and development to secure sustainable supplies of strategic materials for India's future. CSIR-NML's Madras Center has specialized in the indigenization and development of column flotation technology, a state-of-the-art mineral beneficiation process successfully transferred at commercial scale for processing fine and low-grade ores. CSIR-NML's Mineral Processing Division focuses on research and development in mineral characterization, beneficiation, and agglomeration to utilize low-grade ores and minerals. Equipped with advanced lab and pilot-scale facilities, it has conducted systematic research for over 6 decades, enabling multiple commercial beneficiation and agglomeration plants in India and contributing significantly to mineral-based industries. Backed by world-class pilot plants and mineral beneficiation infrastructure, NML transforms laboratory discoveries into industrial-scale realities. The laboratory's integrated facilities, including specialized furnaces for magnesium distillation, 1 ton per day battery recycling plants, and advanced coal characterization laboratories enable technology validation and accelerate industry transfer. Laboratory's rolling mill technology simulates industrial rolling processes, enabling development and optimization of advanced steel products under controlled conditions. To power India's leadership in advanced manufacturing, CSIR-NML established a state-of-the-art laboratory scale inert gas atomizer, making possible the indigenous production of high-purity metal powders for additive manufacturing, inaugurated in 2024 by Director General of CSIR, Dr. N. Kailas Selvi. This cutting-edge facility places India at the global forefront, producing specialized alloy powders for critical sectors such as jewelry, defense, and precision engineering for the very first time in the country. NML has developed India's first indigenous sodium metal technology and is pioneering extraction technologies for tungsten, magnesium, vanadium, scandium, rare earth elements, lithium, cobalt, and nickel. Coal testing and comprehensive chemical analysis form critical services, determining ash content, calorific value, and composition across India's coal fields. CSIR-NML has a long-standing legacy in research and development of magnesium alloys, advancing their production and applications and successful technology transfers to industry. On November 26, 2024, NML's Platinum Jubilee Foundation Day, Dr. N. Kailas Selvi, Director General of CSIR, laid the foundation stone for a magnesium pilot plant designed to produce 120 to 150 kilograms of magnesium metal per day. For the first time, India will produce high-purity magnesium from indigenous dolomite resources. CSIR-NML's high-performance wear and abrasion-resistant steel, engineered for demanding use in excavator buckets and tipper bodies, have been successfully commercialized. This achievement was formally recognized through an appreciation letter from Tata Steel, commending CSIR-NML's pivotal role in developing and transferring this advanced material for real-world, heavy-duty applications. The institution has also developed a sustainable carbon dioxide-based decarburization process that efficiently converts high-carbon ferromanganese to low-carbon ferromanganese, reducing carbon dioxide emissions by over 60% compared to traditional methods, supporting India's growing special steel industry with cleaner and cost-effective technology. But the more transformative work may be happening in recycling. India is the fifth largest producer of electronic waste globally. CSIR-NML has established India's first urban ore recycling center, a pioneering facility dedicated to extracting valuable materials from electronic waste safely and sustainably. The centerpiece is 1 ton per day lithium battery recycling pilot plant. This represents CSIR's first complete holistic process for extracting and separating lithium, nickel, cobalt, manganese, iron, aluminium, copper, and recovering graphite from spent lithium batteries of mixed origin. Metal purities exceed 99.99%. Technologies for recovering precious metals, gold, platinum, and palladium from waste printed circuit boards have been successfully transferred to multiple companies. These technologies support India's vision of a circular economy while creating employment and entrepreneurial opportunities. Together, we can turn what was once seen as waste into the bedrock of a self-reliant future, powering India's ambitions in the green century.
On the critical metals and circular economy front, we are now addressing battery recycling, waste valorization, and green metal themes. We have established the lithium battery recycling plant as well as urban mining center for recovery of critical metals from electronic wastes. The technologies developed in the area of recycling and recovery of critical metals have been transferred to various entrepreneurs across the nation.
Red mud has long challenged the aluminium industry, prompting Niti Aayog to form a consortium led by CSIR-NML to develop a full-scale solution focused on rare earth recovery. In partnership NALCO with Hindalco, Vedanta, and leading research institutions, NML has demonstrated 100 kg scale extraction of aluminium, iron, titanium, and rare earths with impressive results. 87% alumina with 99% purity, 93% iron with 99.7% purity, 86% titania with 90% purity and 90% rare earths with 90% purity. NML has emerged as a leader in developing sensors tailored to specific industrial needs. The Zincometer, a real-time zinc coating weight measurement device for galvanized steel wire, was showcased at Dusseldorf Wire, the world's largest wire trade fair in Germany. CSIR-NML's Hot Dip Process Simulator, or HDPS, enables realistic laboratory scale simulation of galvanizing and galvannealing processes, including for dual-phase steels, supporting advanced coating technology development and industrial adoption. CSIR-NML's advanced research in magnetic materials explores novel alloys and magnetophysical properties, driving innovation in next-generation magnetic applications across industries including automotive and electronics. The institution is also pioneering research on MXenes, advanced 2D materials with exceptional electrical, mechanical and chemical properties that hold promise for next-generation energy storage, sensors and environmental applications. The MagRace technology, a magneto-impedance-based sensor for detecting carburization and defective welds, has been transferred to Arcelor Microsystems in Chandigarh, providing Indian industries with cutting-edge, non-destructive testing capabilities. As the world confronts climate change, CSIR-NML is pioneering green metallurgy solutions. The laboratory has initiated research on hydrogen-based direct reduce iron, developing cleaner steel-making processes. Under the CSIR Carbon Capture and Utilization Mission, NML is testing metal organic frameworks for carbon sequestration. CSIR-NML, in collaboration with MNRE, is going to set up advanced testing facilities to evaluate the performance of metallic materials in gaseous hydrogen transportation and benchmarking, supporting clean energy and hydrogen economy initiatives. CSIR-NML is advancing carbon capture, utilization and storage, or CCUs, research through in-house and mission mode projects. Collaborating with RKDF University Bhopal, the team conducts pilot-scale solar-powered carbon dioxide capture trials and develops technologies for carbon dioxide sequestration and conversion into value-added products, supporting India's net zero goals. The lab's geopolymer technology turns industrial waste into low-carbon cement materials, cutting carbon dioxide emissions by nearly 80%. Its geopolymer cement, paving blocks and rapid road repair solutions are already adopted by industry. The team is now developing self-healing geopolymers next-generation materials with transformative potential. Beyond industrial research, CSIR-NML is strongly committed to social development. Its energy-efficient brass and bell metal melting furnaces have improved the livelihoods of traditional artisans, while its anti-tarnish brass care lacquer now reaches consumers nationwide. Through Skill India initiative, the Integrated Skill Development Program has trained 3,578 individuals between 2021 and 2025. And the Jigyasa program has engaged 6,310 students. The Women Technology Park has further empowered rural women with training in animation, 3D printing, digital skills and entrepreneurship, opening doors to economic independence.
As a constituent laboratory under CSIR, we are deeply rooted in the principle that science must serve society. We have tried to live that principle, enabling industry, enhancing skills in the region, including in and around Jamshedpur, and addressing national priorities.
In 2024-25, as CSIR-NML celebrates its Platinum Jubilee, the laboratory has exceeded ambitious targets: 159 SCI publications, a customer satisfaction index of 4.8, 6 patents filed, 5 technologies developed and 5 technologies transferred. External cash flow of 20.13 crores reflects strong industry confidence. Collaborations spanning defense, atomic energy, space, power, steel, automotive and mining sectors position CSIR-NML at the intersection of India's most critical industries.
At this momentous occasion of Platinum Jubilee celebration, let us not rest on our laurels. Let us see this as a launchpad for the next chapter. Let us reaffirm our commitment to excellence, relevance, and responsibility. Together, we will ensure that CSIR-NML continues to be a national asset, a trusted partner to industry, and a catalyst for materials and metallurgical innovations in India and beyond.
The next 25 years will shape India's technological future. CSIR-NML is preparing to lead this shift. With digital transformation redefining metallurgy, AI and machine learning now drive molecular levels materials research. Its Center of Excellence for Corrosion and Wear-Resistant Coatings targets India's massive GDP losses from wear and corrosion. The Marine Corrosion Research Station in Digha is being upgraded into a modern research and training hub to generate critical coastal performance data and reduce reliance on foreign technology.
Looking ahead, our vision is to harness our legacy while being future-ready to deliver technologies that are relevant to industry, sustainable in impact, and transformative for society. We invite industry partners, startups, MSMEs, academic institutions, and government agencies to collaborate with us. Whether your challenge is in alloy design, corrosion mitigation, green extraction of metals, critical metals recovery, battery recycling, digital process controls, or advanced materials, we have the infrastructure, expertise, and the will to jointly develop solutions for those. Our mantra is honor the past, empower the present, envision a sustainable technology-driven tomorrow.
CSIR-NML has forged partnerships with premier institutions worldwide: University of Stavanger, University of Miskolc, Korea Maritime University, University of Santiago de Compostela, Queen's University Belfast, University of Stuttgart, and many others. These collaborations facilitate knowledge exchange, joint research, and access to global facilities. CSIR-NML, through Academy of Scientific and Innovative Research, offers advanced doctoral and dual degree programs nurturing future researchers and professionals in metallurgy, materials science, and allied fields while complementing its renowned research and industrial consultancy. Domestically, partnerships with IIT Kanpur, IIT Patna, IIT Madras, IIT Roorkee, IIT Kharagpur, IIT Bombay, and numerous other institutions create a vibrant ecosystem for metallurgical research and education. Behind every technology, every breakthrough, every innovation are people, dedicated scientists, skilled technicians, visionary leaders, and supportive staff who have devoted their careers to advancing India's capabilities. Mr. Anand Mahindra, Chairman of Mahindra Group, wrote, "As the world reorganizes supply chains and nations strive for greater self-reliance, NML's work is key to enabling India to emerge stronger, resilient, and ready to lead." Dr. V.K. Saraswat, member of Niti Aayog, emphasized, this institute has a more important role to play in developing indigenous technology for critical metal extraction and import substitution. Dr. Shankar Venugopal, Vice President of Mahindra & Mahindra, said, "For a material scientist like me, a visit to NML is a dream come true. NML can play a key role in creating a materials technology roadmap for India."
As we commemorate 75 years of remarkable achievements, I, on behalf of present CSIR-NML family, thank the many generations of scientists and support staffs whose dedication has brought us here. I thank our industry collaborators, government agencies, and research partners for their trust and engagement. "75
years ago, a vision took shape in the Steel City. Today that vision has grown into a legacy of innovation that spans continents and touches lives across the globe. From Nehru's inauguration in 1950 to the Magnesium Pilot Plant Foundation in 2024, from the first certified reference materials to the last urban ore recycling center, CSIR-NML has remained steadfastly committed to one mission: enabling India's technological sovereignty. As India moves steadily towards its vision of becoming a developed nation by 2047, and as we strengthen our place as a global leader in science and technology, CSIR, National Metallurgical Laboratory, keeps propelling progress through every innovation, breakthrough and discovery. The young scientists and researchers working in NML's laboratories today carry forward the spirit that began with Bhatnagar's vision. They're solving problems that haven't been fully defined yet. They are developing materials for applications we are only beginning to imagine. They are creating technologies that will power India's next chapter. The next 25 years will be defined by challenges we must overcome: climate change, resource scarcity, technological disruption, geopolitical shifts. But if history is any guide, CSIR-NML will be at the forefront, transforming challenges into opportunities and continuing to forge India's future. Because, in the end, this is not just the story of a laboratory. It is the story of India's determination to master its destiny through science, technology, and innovation. It is the story of silent strength that holds up buildings, powers turbines, protects soldiers, enables spacecraft, and builds bridges to our shared future. CSIR National Metallurgical Laboratory, 75 years of excellence, a lifetime of impact, an infinite future of possibilities.